All right, so section 5.4, adding and subtracting rational expressions with like denominators. That's actually the key to this whole lesson, is that the denominators are always going to be the same, so it makes adding and subtracting them very easy. I put a little quick reminder right here just to kind of show you what that means. Now, the two little examples I'm going to show you guys, they're not meant to be difficult, so don't think like, oh, this is going to be super easy. Like, well, I'm about to show you something that's super easy. Okay, if I were to give you like a 1/7, and I say add it to 4/7, okay, this is the process that's supposed to happen, but most of us don't do it. First off, you're going to notice that the denominators are the same. So anytime you have two fractions that are either adding or subtracting and their denominators are the same, that means the denominator will stay the same. Okay, so it's 1/7 plus 4/7. That's going to result in a seventh of something. Now, usually the way you're supposed to do it when they teach it to you guys at very first time ever, they'll tell you get the numerators and put them together on top. Now, like I said, most people don't do that, but that's actually going to be something that's going to be useful for this lesson. Okay, so I'm just going to show you this step. So 1 plus 4, right, which comes out to 5/7. And then at that point, check to see if you can simplify anything, right, by reducing or anything like that, which we can't. So we're done, okay? So there's one easy example. Another simple example will be something like this. If I do like a 10/11 minus a 4/11. Okay, again, notice how the denominators are identical, right? If the denominators match, then it doesn't change. So I'm still going to put 11 right there. Okay, so what we're going to do right now is just get the numerators and write them out on top. Now, you're going to notice that whenever there's a minus or even a plus, you're supposed to distribute that into the other numbers that are behind it. So this is going to become 10 minus 4. And I know you're thinking like, well, duh, you're going to subtract. But again, this will make a lot more sense when you start seeing some of the examples we're about to do. I'm just trying to remind you guys to distribute those signs, okay? Make sure you distribute those signs. 10 minus 10 minus 4 is 6, so this becomes 6/11, and you're done, okay? So pretty easy, right? Not too hard to do those type of things. What we're going to do today won't be much harder. We are going to have variables, but we're not going to have a lot of like trickiness to the problems. It might look harder, but the idea is this, okay? Same denominator, combine them, and reduce as much as possible. So let me show you this one right here. So I know this looks way different than like a third plus 2/3 or something like that, okay? But it's the same idea. Notice how they have the same denominator, right? The first fraction has a 30x on the bottom. The second fraction has a 30x on the bottom. That makes them like denominators, which means that I can just kind of combine them. I can put them together. Now, don't forget that this negative sign has to be carried over to that 4x, okay? So we're going to distribute it there, okay? Though there's not much to distribute, but, you know, if there were two terms, then you would distribute it to both terms. So here's my first step. I'm going to just write a fraction and put 30x on the bottom, okay? On top, I'm going to put all the terms on the numerator up on top. So x minus 5y, and then minus 4x. Now just combine any like terms that you have. So x minus 4x is negative 3x minus 5y over 30x. And then the last thing you want to ask yourself is, can I simplify this in any way? So like the top part, can I take out any numbers that they have in common for the top? No, right? They don't have any letters in common on top. Can I reduce anything, cancel anything out? No, I'm done. So that's it. This problem's finished. Okay? So there's not much more to do with that one. Just combine it and simplify if possible. Okay? Ask yourself, can I factor? Okay?
So if the top 3x was a positive, can you distribute it? I mean, can you divide the 3 and the 30?
No, because remember, if I want to cancel or reduce, this with this, then it cannot be stuck to another number. Remember, the minuses and pluses in the middle hold stuff together, right? So I can't just start like chopping off things here and there. I have to make sure the whole term, the whole binomial has to disappear, not just little pieces. So there's the first one. Let me show you the second one. Okay, right there. Thank you. All right, so example number 2, we're going to simplify that. Okay, again, it looks complicated, but it really isn't. The idea is simple. Same denominator, so keep it, and then just add or subtract the numerators. Okay, so let's go ahead and get this one started. So since they both have a 15x squared in the denominator, I'm just going to put 15x squared right here. Okay, now I'm going to write down everything that's on the top, but remember this plus is going to distribute here and there. But the nice thing about distributing positives is that it doesn't change anything, which is nice. So that means it's going to be x plus 3y plus x minus 2y. Now let's combine like terms on the top. Okay, so I have x plus x, that's 2x. 3y minus 2y is positive y over 15x squared. Can I reduce, well, on the top, can I factor anything out? No, and the bottom is a monomial, so you can't. Okay, and since the top is a binomial, I can't just kind of like take an x out of the top and bottom. I can't do that. So this problem's done. Whoops, let me fix that. But yeah, so you can see like these things don't take a lot of time to do. You just kind of have to look at it piece by piece, see what's available, add or subtract, and you're done. Any questions on this one? All right, let's go to example 3. We got 4 examples, okay? So example 3 is one where at the very end we might have to factor out the bottom just to see if once we're done adding on the top, if maybe there's a matching piece, okay? So don't just leave it the way it is. Like I said, always at the end, once you've combined everything, ask yourself, can I factor top? Can I factor bottom? Can I cancel or reduce, right? Always want to do that stuff. Because again, why do I always go through every single one of those questions? That's what simplify means, right? Reduce, factor, cancel out as much as possible. Make it as simple as possible. Okay, so get rid of everything that they have in common. So this one looks like it could be difficult to do, but again, just follow the rule, right? The rule says if you're adding 2 fractions that have the same denominator, then you're going to keep the denominator. So notice I didn't do anything special with the bottom part. And then you're just going to combine the numerators. Now this is a plus, so when I distribute it, it will not change anything. So it's going to be m minus 6 plus 2m plus 4. So combine your like terms on top. So m plus 2m, that's 3m. Negative 6 plus 4 is negative 2. And then on the bottom, I have m squared plus 3m minus 10, right? M squared plus 3m minus 10. But now I'm going to do a little bit of side work, because I can probably factor that trinomial, and maybe there's a 3m minus 2 in there. Maybe not. Who knows? So let's see. M squared plus 3m minus 10. A is 1. Whoops. B is 3. And C is negative 10. So if I do the x method here, that comes out to negative 10 and a positive 3. I need 2 numbers that multiply to negative 10, add up to 3. A 2 and a 5, which one's positive? The 5, right? So, not the y, the 5. 5 minus 2. So, alright, so here we go. M plus 5, m minus 2. So I'm going to write that down in the next step, and then we'll see if we can do anything here. So 3m minus 2 over m plus 5 times m minus 2. Am I able to cancel this part out right here?
No.
But they match. It's touching the 3. Everything has to go, not just parts of it, right? So, so I leave it like that. I'm done. So did I waste time factoring it? Sure. But then again, simplify means to factor, so I guess I'm just following directions. Okay? So, all right, there you go. One more, and then I'm going to give you guys your homework. You'll have a lot of time to do homework, so you should be able to finish this hopefully in class. Now this one has something on the bottom. Yes, matching like terms, but notice those like terms on the bottom, those are differences of two squares. Right? 4r squared minus 1. I can write 4r squared as 2r, quantity squared, and I can write 1 as 1 quantity squared. Okay? So I'm gonna go ahead and combine them because they both have the same denominator. So I'm gonna put 4r squared minus 1. And on top, when I combine that, don't forget to distribute that minus. Now the minus is going to change stuff, okay? It's going to mess with the r plus 1. It's going to change all the signs. So this is going to be r minus 3 minus r minus 1. Well, r minus r is 0, and negative 3 minus 1 is negative 4. And this is just 4r squared minus 1. But again, since it says simplify, we're supposed to try to break this down as much as possible. And I know that 4r squared minus 1 is a difference of two squares. So let me write it out really quick. So 4r squared minus 1 is the same as, let me put this right here, 2r quantity squared. That gives me 4r squared. And then 1 quantity squared gives me 1. So that is going to be a 2r minus 1, 2r plus 1. So that's how it factors. So let me just write that out here. Negative 4, 2r minus 1, 2r plus 1. And at that point, I can't cancel anything, so I'm just going to put a box around there, and I'm done. So here's what your homework is. Basically just like terms, combining stuff together, and that's it.